Hello everyone, once again, we are still dealing with quadratic sequences. So right here we are given a sequence, a quadratic sequence that starts with -1, 2, 7, and 14, right? And then we know that the nth term of a quadratic sequence is given as tn is equal to an squared plus bn plus c. So now our duty here is to find the values of a, b, and c, right? Okay, so first and foremost, guys, we know that a quadratic sequence has got a constant second difference, right? So our sequence starts with -1, 2, in fact, let me write 2 here, then 7, then 14, right? Then it continues. So we're going to find the first difference between these terms. So 2 minus minus 1, that is 2 minus -1, right? So that's obviously 2 plus 1, which is 3, right? Then 7 minus 2, that is 5. Then 14 minus 7, that is 7, right? Then this is the first difference, and as you guys can see that the first difference is not constant. If this difference was constant, then we're going to be speaking about linear sequences, right? So we continue to find the second difference. The second difference is going to be 5 minus 3, that is 2, and then 7 minus 5, that is 2 also, right? So from the previous video, we actually were able to prove that quadratic sequences have got a constant second difference, right? And then we came up, the term here in terms of A, B, and C, and here and here. So initially, A plus B plus C was the term that corresponded to -1, or will be the term that will correspond to -1. I think let me just get that. As you guys can see from what we did last time, right? So A plus B plus C is corresponding to -1 right here, right? Then this one now, 3A plus B, 3A plus B corresponds to 3 right here. Then the last one, which is this one, 2A will correspond to 2 in this one. So 2A will equals to 2, right? So we're going to solve for A and B and C simultaneously, right? So there are quite a number of ways to solve these things. So we've got 3 equations, right? So from equation 3, which is 2A that equals to 2, A is equals to what? A equals to 1, right? So we are able to find A, which equals to 1, and we are gonna substitute A that equals to 1 in the second equation, right? Okay, so, and I want you guys to take note that I'm going to have substituted A equals to 1 in this equation because there is also another missing variable, you see? So it's going to be 3 times 1 plus B, which equals to 3, right? Okay. Okay, cool. All right. So basically, it's 3 plus B is equals to 3. So B here will equals to 3 minus 3, which is 0. Hence, B is 0, right? Okay. All right. So we've got A, then we've got B, and lastly, we're looking for C now. So we're going to substitute A is equals to 1 and B is equals to 0 in equation 1, right? Okay, so equation 1 is A plus B plus C is equals to -1, right? So A is 1, plus B is 0, plus C this equals to -1, right? So, so this is 1 plus c is equals to -1. So c is equals to -1 minus 1. Hence c is equals to -2, right? Okay, so basically our nth term for this specific quadratic sequence, for this one right here, our nth term is going to be Tn is equals to, what is a? A is 1, so it's n squared plus bn. B is 0, so we don't have to write there. Okay, or we can say plus 0n, then c is -2, right? So our final thing is Tn is equals to n squared minus 2, right? This is the nth term that corresponds to that sequence right there. You know what I'm saying? Let's say, for example, we wanted to find, I don't know, the third term. Ne? We can still use this to find the third term. We know that the third term is equals to 7 right here. So having found this Tn, we can actually find the third term. You know, T3 will be 3 squared minus 2. 3 squared is 9, minus 2 is 7. You see? So we're able to find the third term. So having this, we can find any term in this particular quadratic sequence. Alright guys, do stay blessed and enjoy the rest of your day.